Hi. So I'm going to go ahead and do some reading comprehension today. So I'm going to test 75, section 4. Okay. And getting into reading comp. So first I'm just going to do the passage only view. I actually want to go to the last, passage with question. Okay, there we go. I want to go to the last passage. Okay, passage only view. All right, great. Okay, so I believe this is the science passage for this section. Okay. Right. So to glass researchers, it seems somewhat strange that many people throughout the world share the persistent belief that window glass flows slowly downward like a very viscous liquid. Okay, so this is key because we do see a bit of a conflict here in that the glass researchers find it strange that people have this belief. And so why might they find it strange? Well, I would assume because it's incorrect. And when they talk about it being a persistent belief, so that's a belief that persists even though it's not true. So why would it be strange that that belief continues for people? Well, it would be strange because potentially they are being confronted with evidence to the contrary, but they continue to hold on to this belief. So that's maybe reading into it a little bit too much, but at the very least, we do have this thing that glass researchers find it strange that many people have this belief. Okay. Repeated in reference books in science classes and elsewhere, the idea, all right, and what idea is that? They're referring to this belief again, the belief that glass flows slowly downward like a very viscous liquid. So this idea is repeated in reference books in science classes and elsewhere, and has often been invoked to explain Ripley windows in old houses. The origins of the myth, so we go from persistent belief to idea to myth, they're all talking about the same thing. The origins of the myth are unclear, but the confusion, okay, probably arose partly from a misunderstanding of the fact that the atoms in glass are not arranged in a fixed crystal structure. Okay, so it's this idea that glass flows slowly downward like a very viscous liquid is a myth. It has caused confusion, right? Because that's not actually true. It's a persistent belief that many people have, and glass researchers find it strange. And it arose partly from a misunderstanding of a fact. Okay, so there's something true here. This is actually factual, but it was misunderstood, and then this viscous, downward flowing, viscous liquid idea came out of that. So it's like a misinterpretation of something that's actually true. Okay. In this respect, the structure of liquid glass and the structure of solid glass are very similar, but thermodynamically they are not the same. Okay. So like the atoms are not arranged in a fixed crystal structure. So liquid glass and solid glass are similar in that way, but thermodynamically they're different. So this would also be a key point. Glass does not have a precise freezing point. Rather, it has what is known as a glass transition temperature. Okay, so freezing point would be where something turns from a liquid into a solid, right? And so glass doesn't actually have a precise freezing point where it turns from liquid glass to solid glass. It has a glass transition temperature, which is a range of a few hundred degrees Celsius. Okay, so rather than being like, so water, for example, freezes at 0 degrees Celsius. Now, they use Celsius here. I'm Canadian, so I'm used to using Celsius for everything. If you're American and you're used to using Fahrenheit, I assume that you still would have encountered Celsius and like the freezing point and the boiling point of water in Celsius in like high school science or as even earlier in science classes. But yeah, I am not aware off the top of my head what that would be in Fahrenheit. But in any case, all we really need to know here is that there's something about glass that's a little bit strange, and that it has this transition temperature, which is a range rather than one point, like a precise point versus a range. Cooled below the lower end of this range, molten glass retains an amorphous atomic structure, but it takes on the physical properties of a solid. Okay, so it retains the atomic structure, but has the physical properties of a solid. So it actually wouldn't then flow downward like a very viscous liquid because it has the physical properties of a solid. All right, so this one I think is a little bit, it's, yeah, I would say this is confusing as far as subject matter goes. Like you've got a lot going on here, but I think the key is to look at it as I've got these two kind of competing ideas. One of them is a myth, right? And for some reason, this myth, like it's persistent, right? And why might that be? Like, why might people continue to believe something even though there's evidence that shows that it's not true? Well, if it's repeated in reference books and science classes and it explains something that we can actually see with our own eyes, which is those Ripley windows in old houses, then maybe there's something about it that intuitively makes sense. But then when you look closer at the evidence, you find out that it's not true. And that is a bit of a pattern that we see on the LSAT, is that maybe at a surface level, there's one interpretation of the evidence. But if you analyze more deeply, then you can disprove that interpretation and kind of recognize that that interpretation is superficial and isn't based on evidence and reason. It's actually based on assumptions. Okay. So going past assumptions and recognizing, oh, that's just an assumption, that's not based on clear evidence and sound reasoning. I think that's part of the skill set that you're being tested on. And so if you start developing more of an eye toward those things, recognizing like, oh, okay, this is someone's made an assumption or that seems right, like, oh, that like kind of, that kind of makes sense, like a certain explanation, but they haven't dug any deeper. Yeah, that's sort of what we're looking at here, right? Okay, so a new study debunks the persistent belief, right? So that's great. We've got debunking this belief. That stained glass windows in medieval cathedrals are noticeably thicker at the bottom because the glass flows downward. Okay, so they're not actually debunking the idea that they're thicker at the bottom, but they are debunking the explanation as to why they are thicker at the bottom, right? So the belief is that glass flows downward. And here they're bringing up this idea about how this particular belief, this myth, is used to explain Ripley windows in old houses, and in this case, stained glass windows in medieval cathedrals, being thicker at the bottom. Under the force of gravity, certain solid materials, including glass, can flow slightly. Okay, so this is interesting. This is kind of a concession, right? So they are saying that it's possible for glass to flow slightly. right? But, and here's where the research comes in, right, of this new study, but Brazilian researcher Edgar Dutra's Noto has calculated the time needed for viscous flow to change the thickness of different types of glass by a noticeable amount. And according to his calculations, medieval cathedral glass would require a period well beyond the age of the universe. Okay, so definitely that's not what's happening with this medieval cathedral glass, according to Zanotto's calculations. Okay, so Brazilian researcher Zanotto has disproven or debunked this kind of, theory or idea about why those stained glass windows are thicker at the bottom. All right, and then it goes into detail a little bit more. So the chemical composition of the glass determines the rate of flow. Even germanium oxide glass, which flows more easily than other types, would take many trillions of years to sag noticeably, right? So way, 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 way more time than as long as the medieval glass has been around. Medieval stained glass contains impurities that could lower the viscosity and speed the flow to some degree, but even a significant difference in this regard would not alter the conclusion. So it is interesting how the author here keeps bringing up like possible objections or exceptions to what Zanotto has said, and then or to the ultimate conclusion, and then shooting them down, right? So they bring up this idea that certain solid materials, including glass, can actually flow, but then they say no, but it's not possible because of the time frame, right? The calculations show that's not going to work. And then they say, oh, it contains impurities that could lower the viscosity and speed up the flow to some degree, but it's not gonna actually make a difference, right? So yeah, even a significant difference in this regard. So they keep kind of bringing up these things and making like very small concessions and sort of saying, even if we consider the most like extreme possibility or the highest rate of flow that we would potentially see with glass, it's still not possible that that would explain what is going on with these cathedrals because they're only a few hundred years old, right? Several hundred years old. Okay, the study demonstrates dramatically what many scientists had reasoned earlier based on information such as the fact that for glass to have more than a negligible ability to flow, it would have to be heated to at least 350 degrees Celsius. Okay, which is like, I mean, that's how high you would, I mean, that's, yeah, 3 times plus the boiling point of water, right? So it's like ridiculously high. So that's not a temperature that you would actually have, like that's not a temperature that this glass would be heated to over time, right? If it's just sitting in those windows. Yeah, okay. The difference in thickness sometimes observed in antique windows probably results instead from glass manufacturing methods. So then they come up with an alternate explanation, right? So not only do they debunk the viscous liquid, the flow explanation, they also are now providing probable explanation. Okay. Until the 19th century, the only way to make window glass was to blow molten glass into a large globe and then flatten it into a disc. Whirling the disc introduced ripples and thickened the edges. To achieve structural stability, it would have made sense to install these panes in such a way that the thick portions were at the bottom. Okay, so there were actually portions of glass that differed in their thickness because of the way that they were manufactured by flattening them. So that's how they used to do things, right? I'd say until the 19th century. Okay. Later, glass was drawn into sheets by pulling it from the melt on a rod, a method that made windows more uniform. Today, most window glass is made by floating liquid glass in molten tin. this process makes the surface extremely flat. Okay, so that's just to show the difference between the manufacturing methods when those old houses and when the cathedrals were built, the difference in the manufacturing methods to make those things versus window glass today, which doesn't have that same appearance of being thicker at the bottom, right? Yeah. So, I mean, that's quite a detailed analysis of the passage. I'd say that the first paragraph here is probably the most important, and it's also the one that's maybe the most challenging to analyze. But once you get the first paragraph, then just seeing how the other paragraphs fit in becomes a bit easier. And yeah, the colors that I'm using, the highlighter colors that I'm using, there's not a lot of organization to that. So mostly I just switch colors when I feel like I've used one color a lot, and then I kind of want to say, oh, but this is also important. And so you can see I highlighted a whole bunch in the first paragraph, and I switched colors a couple times in the second, and then I didn't really switch towards the end. So I think the more mental effort I'm putting in to try to understand how things fit together, probably that is what is made like visual by the highlighter, right? So I'm sort of using more highlighter when I'm using more effort to understand something. And then as I find it makes a little bit more sense to me, and I feel like I have a pretty good picture of what's going on in my head, then I don't feel like I need to be using the highlighter as much. Yeah, so don't pay too much attention to the, what I highlighted versus what I didn't. I just use it as a bit of a tool to maintain my focus as I'm going through and trying to understand what's going on. Okay, so let's get into the questions. So the main point. Now, I would definitely think that the main point is to debunk this belief, right? And that even the explanation, like the alternative explanation that's probable, the reason that that's brought up, I think, is to debunk the belief. Because if the belief is persisting because people are like, oh, well, it explains this thing that I see in these old houses and in cathedrals. So I think sometimes when someone can actually use their own senses to investigate, they kind of will say, okay, but that still needs an explanation. So even though you can still disprove, and in the study they did disprove the, I'm just going to call it the flow theory. So they did disprove the flow theory in that study, right? And so even though someone could look at glass and say, oh, well, then how do you explain that the glass is thicker at the bottom in these old buildings? Like a perfectly reasonable response to that would be, well, I don't know why that is. I just know that the flow theory cannot explain it, right? That the flow theory has failed to explain it. So to debunk that theory, they don't have to come up with like a real answer to why that is, right? They don't actually have to do that. That's like a separate issue, answering that question, right? They could just say, well, I don't know, right? That's like a perfectly reasonable response. And it's better to be left with, I don't know why that is, than to persist in believing an incorrect explanation. At least I think so from the standpoint of what's reasonable, right? So, but they do, I think probably that the reason they actually go into why do we like the observation of that is because the fact that people can observe it with their own eyes is probably one of the reasons why they find the flow theory compelling in the first place. So if rather than just saying, well, we know it's not the flow theory, they can actually go in and offer an alternative explanation that makes sense and is explainable like that, that I think is almost, more compelling than even the scientific study that said that it's not possible that the flow theory would be correct. So anyways, but yeah, I like I said, that fourth paragraph, I do think is in service of the goal of debunking that belief. So I would, I would definitely be focused on that in terms of the main point. Okay, so A, Zanotto's research has proven that the amount of time required for viscous flow to change the thickness of medieval cathedral glass would be greater than the age of the universe. That is true, right? But it's way too specific, right? Like it just focuses on one little part of the whole passage. It's important, but it's just like a piece of evidence, right? It doesn't mention anything about this persistent belief that is mentioned over and over and over again. Okay. B, the technology of window glass production has progressed substantially from medieval stained glass techniques to today's production. Again, too specific, doesn't cover everything that we need and doesn't mention anything about this belief. So I would be looking for that. So like contrary to a commonly held belief, noticeable differences in the thickness between the top and the bottom of some old glass windows are not due to the flowing of solid glass, but probably result instead from old glassworking techniques. This is better. I don't love it, honestly. It still seems a little bit too specific. Contrary to a commonly held belief, are not due to that, but they. So I would keep E for now. Let's see if either C or D is better than E. C, after years of investigation motivated partly by a common misunderstanding about the structure of glass, scientists have developed ways of precisely calculating even extremely slow rates of gravity-induced flow in solids such as glass. No. This one I actually think is incorrect. I do not think that that's stated in the passage. Like years of investigation and motivated by a common misunderstanding. I don't see evidence that that's the case. And then they've developed ways of precisely calculating. And the precision of the calculation it just has calculated the time needed. And it would require a period well beyond the age of the universe. I don't know how precise that even is, right? Like many trillions of years. We just know that it's for sure way, way longer, right? Than as long as the medieval cathedrals have been around. So yeah, that would be the first one where I'd say I think that is actually unsupported, even as a statement, like a restatement of the passage. Okay. D, recent research provides evidence that although solid glass flows slightly under the influence of gravity, such flow is only one of several factors that have contributed to the noticeable differences. No, this is also incorrect. So they don't say that flow is a factor contributing to the thickness at all. They say that the difference in thickness probably results instead from glass manufacturing methods, right? So It's not the flow theory plus the manufacturing methods as like two contributing factors. It's the glass manufacturing methods is the reason, and the flow theory is incorrect. So that would also be out. So yeah, E's got to be the correct answer. Like I said, I don't love it. Like if I were being tasked with stating the main point of the passage, I probably would have maybe. I think I may have come up with something a bit different. But like I said, I wasn't ready to eliminate this one, and C and D are definitely both worse than E. So moment of truth, and E is the correct answer. Okay, moving on. The passage most helps to answer which one of the following questions. A, what is one way in which 17th century window pane manufacturing techniques differ from those commonly used in medieval times? No idea, right? So 17th century is still before the 19th century, and they have until the 19th century, and then later being later, and then today, right? So I can't answer that. What is one way in which 19th century window pane manufacturing techniques differ from those commonly used today? Again, if it's until the 19th century, I would think this method would be like before the 19th century. So this little interesting, but yeah, not sure about that. So I'm actually gonna keep this one open, because maybe until the 19th century would include at least part of the 19th century. And then there's also this period, this kind of later period where glass was drawn into sheets by pulling it from the melt on a rod, versus today where it's made by floating liquid glass in molten tin. So those are different methods. So yeah, maybe it's B. C, was glass ever used in windows prior to medieval times? I don't know about that. I know it was used in medieval times, but I don't know if it was used before. Are unevenly thick stained glass windows ever made of germanium oxide glass? Yeah, no idea. I do know that even germanium oxide glass, which flows more easily than other types, would take many trillions of years to sag noticeably. But I don't know if that's what the window panes were made of. And E, how did there come to be impurities in medieval stained glass? I know that there are impurities in medieval stained glass, but I don't know how they came to be there. So it's got to be B. And that issue of like 19th century, and here we have 19th century. Yeah, I mean, until the 19th century, is that like until 1899, and then as soon as it was 1900, or sorry, the 19th century would be the 1800s. Yes? Am I getting myself confused? Yes, it would be, sorry, it would be the 1800s. So it would be like until 1799. And then as soon as it was 1800, then we're in the 19th century. And yeah, and then window pane manufacturing techniques change. So yeah, the reason I'm absolutely sure about that, though, is because I could still compare later to today, right? So yeah, like after the end of the 18th century. So yeah, B, I think I can support. Yeah, there we go. Okay. 23. Which one of the following best summarizes the author's view of the results of Sonoto's study? So the author seems to be on board with Sonoto's results. What did the results do? The results debunk the flow theory. So let's see. A, they provide some important quantitative data to support a view that was already held by many scientists. So it was a view already held by many scientists, right? The study demonstrates dramatically what many scientists had reasoned earlier based on other information. So, but they do provide some important quantitative data to support a view that was already held with many scientists. Yeah, I like that, but I'll keep going. B, they have stimulated important new research. No. C, they offer a highly plausible explanation of how a mistaken hypothesis came to be widely believed. No, actually. So the study doesn't tell us anything about why people believed the flow idea. It just debunks it. D, they provide a conceptual basis for reconciling two views that were thought incompatible. No. E, they suggest that neither of two hypotheses adequately explains puzzling phenomena. Nope, not that either. So it's got to be A. Okay. For any of these, you can definitely let me know if I'm completely brushing over an answer choice that you'd like me to kind of debunk, I guess, in more depth. Right. The passage suggests that the atomic structure of glass is such that glass will. So where do they talk about? So amorphous atomic structure. It's not fixed crystal. All right, let's see. That glass will behave as a liquid even though it has certain properties of solids. Well, it says it retains an amorphous atomic structure but takes on the physical properties of a solid. Doesn't really say like certain properties of solids. It just says the physical properties of a solid. Let's see. Be noticeably deformed by the force of its own weight over a period of a few millennia? No. Yeah, like the period would be well beyond the age of the universe and by the force of its own weight. I mean, I suppose gravity, right? But yeah, I don't see that. Behave as a solid even when it has reached its glass transition temperature. No. Okay, so maybe it is A. Behave as a liquid. Huh. Yeah, this one I'm not sure about. Let's see. Such as the fact that for glass to have a more than negligible ability to flow, it would have to be heated to at least 350 degrees Celsius. I don't know what its transition temperature is. Behave as a solid even when it has reached its glass transition temperature. No, because I think typically a range of a few hundred degrees Celsius, cooled below the lower end of this range, it retains an amorphous atomic structure but takes on physical properties of a solid. No. And this, yeah, stop flowing only if they're arranged in a fixed crystalline structure. No, I don't like that either. I'm going to go with A, even though I wasn't a big fan of it before, because C, D, and E, yeah, I'm just not actually seeing evidence for this. Whereas A, I do get a little bit. Yeah. So I'm gonna go with A, but I'm not super clear on this one. Okay, and it is D. Flow downward under its own weight if it is heated to its glass transition temperature. Where the passage suggests this. So this one's a little bit more of an inference than that the passage actually states it. But it would have to be heated to that. But I guess if it is heated to that, then it would flow. Then it would have a more than negligible ability to flow. And then glass transition temperature. I mean, I suppose they're sort of suggesting that this would be like the lower range of its glass transition temperature. So when it's heated above that, then it would like continue to have the amorphous atomic structure, but it would go back to having the physical properties of a liquid and therefore flow downward like a liquid does. And I guess the under its own weight thing, yeah, it does make sense. That's just gravity. Alrighty, well, there you go. Got one wrong. Okay, we're moving on. The author of the passage attributes the belief that window glass flows noticeably downward over time to the erroneous assumption that what? Okay, the erroneous assumption that so yeah, keep looking through here. So the atomic structure of solid glass is crystalline rather than amorphous. No. So it seems to come from the fact that it's not crystalline, which is a fact, but the assumption is that because it's not crystalline, that it would behave like a liquid, that it would take on the physical properties of a liquid. Okay. B, the amorphous atomic structure of glass causes it to behave like a very viscous liquid, even in its solid form. Yeah, so I like that. That seems to match, right? So the belief is that it flows like a very viscous liquid, and the confusion arises from the fact that it doesn't have a crystalline structure. And so they're assuming that the fact that it doesn't have a crystalline structure would cause it to behave like a liquid rather than a solid. So I do like B. C, methods of glassmaking in medieval times were similar to methods used in modern times. No. So they don't have any assumption about what the methods were. The methods come up later in giving a different explanation. People aren't really thinking about what the methods are and what the difference might be between them. They're not actually really considering that when they're thinking or having this idea, this like flow idea. D, the transition temperature of glass used in medieval windows is the same of that in modern times. No, they're not really thinking about transition temperature either. E, liquid glass and solid glass are thermodynamically dissimilar. No, so so here the author kind of clears that up actually by saying that they are not the same, that they are dissimilar thermodynamically, even though their structure is similar. So I'm going to eliminate that one as well, because that's not part of the myth. That's part of what the author is saying to push back on the myth, right? Or to begin to debunk it. So B. All right. Redemption from 24. All right, 26. Which one of the following is most analogous to the persistent belief about glass described in the passage? A, most people believe that the tendency of certain fabrics to become wrinkled cannot be corrected during the manufacturing process. No, I don't. I don't see a connection there. So I would, yeah, A doesn't, I don't see a connection. B, most people believe that certain flaws in early pottery were caused by the material used rather than the process used in manufacturing the pottery. Potentially, right? So the people believe that the inconsistency, right, and the thickness was caused by the fact that it's glass and the properties of glass rather than the process of manufacturing the windows. So maybe B. C, most people believe that inadequate knowledge of manufacturing techniques shortens the lifespan of major appliances. I don't see a connection there. D, most people believe that modern furniture made on an assembly line is inferior to individually crafted furniture. I don't see a connection there either. E, most people believe that modern buildings are able to withstand earthquakes because they are made from more durable materials than were older buildings. No. So there isn't so much a comparison between, like, the belief about glass, I don't think is very much like a comparison between current techniques and early techniques. They weren't really thinking about the technique of making the windows. They're thinking about glass just as a substance and what are the properties of glass. So I think here they're thinking about the material of the pottery. And so if you were to make pottery now, it would, but with that same material, that they don't think there would really be a difference. Like same with the glass, they're thinking that that flow impacted the thickness of the glass over time, right? That it was flowing downward, and then that would explain why it was thicker downward, right? Thicker towards the bottom. So yeah, there I don't really see this as being, you know, comparison of previous techniques to current techniques, but rather just that material that was used previously has a certain property, and they're assuming that that's the reason that it looks the way that it does now. So I'd go with B. Right, last one. 27. The passage suggests that which one of the following statements accurately characterizes the transition temperature of glass? Okay, so the transition temperature of glass is typically a range of a few hundred degrees Celsius. And yeah, it doesn't have a precise freezing point, so we'll see. The transition temperature is higher for medieval glass than for modern glass. We don't know about that. It has only recently been calculated with precision. No, it's not precise. Its upper extreme is well above 350 degrees Celsius. Well above. Possibly. D, it does not affect the tendency of some kinds of glass to flow downward. And for some types of glass, it is a specific temperature well below 350 degrees Celsius. Don't like those either. So I guess 350, this is again the passage suggests rather than the passage states. So yeah, a range of a few hundred degrees Celsius, I'd say if the lower end is where it would transition and become solid, or in the opposite direction, transition and become liquid, then sure. It'd have to be heated to at least 350 degrees Celsius. So that would be the kind of minimum, right? And the bottom of its range, the range of the transition temperature. So yeah, I would go with C here. As you can tell, I'm not 100% sure, but that's the one that I think is the best supported. And again, we're dealing with a suggests rather than states. Okay, and it is C. So yeah, for me, 24, obviously, as I got it wrong, and 27, I would say were probably the most challenging. And both of those, we have the word suggests. Whereas here, the author of the passage attributes to what? We're going to get more. This is, yeah, an analogy. What do we have for 23? Summarizes the author's view. Most helps answer which one of the following questions, so we can actually answer the question using info in the passage. And here we have states the main point. But yeah, the suggests ones, we're not going to get the most compelling evidence necessarily, but we just have to go with like the best one. Yeah, I really should have known for 24 not to pick A, because A is more in line with the erroneous belief than it is with the correct the correct interpretation of the fact that atomic structure of glass is not crystalline, right? So the erroneous belief is that it will behave as a liquid because it's not crystalline. And so A actually would be the opposite of what the passage is suggesting, because the passage spends all this time actually debunking that idea. But yeah, I just did not feel confident looking through C, D, and E, and dealing with what could I possibly like the connections that I could make between this 350 degrees Celsius line here and the glass transition temperature range up there. Yeah, I didn't really feel confident connecting those things, but that's what I needed to do for 24 to get the right answer. If I had done that, I would have gotten the right answer. And that's what I needed to do to get the correct answer for 27. So that was the part where my comprehension of it was lacking. Yeah. Okay. So that's my super, super long, fairly detailed analysis of this passage. Like I said, if you have any further questions or want clarification, please let me know. Yeah. Alrighty.